Assalamualaikum and good morning to all 4B students. So today you're going to learn new chapter, chapter 4, the periodic table of elements. So this is the periodic table of elements, okay? So it classifies non-chemical elements in a table according to certain characteristics. So this is your first subtopic, 4.1, the development of periodic table. Okay, many theories were explained by scientists before the modern periodic table of elements was produced. So these are the scientists involved in the development of the periodic table of elements. So the first one is Antoine Lavoisier. So he classified elements according to certain groups such as gases, nonmetals, metals, and metal oxides. His classification was less accurate because he also classified light, heat, and fuel compounds. Besides, there were several elements that were classified into the same group but showed different chemical properties. Second one is Johann W. de Bruijn. Okay, so he classified three elements with similar characteristics into groups known as triads. But his classification was limited to several elements only. And number 3 is John Newlands. He arranged elements according to their increasing atomic masses and arranged seven elements in a row because he found that the chemical and physical properties of the first element recurred at every 8th element, and it calls law of octaves. Okay, the fourth is Lothar Meyer. Okay, he plotted the graph of atomic volume against atomic mass of elements. The element at equivalent positions on the curve of the graph had similar chemical properties. Okay, the fifth one is Dmitry Mendeleev. So he arranged the elements according to the increasing atomic masses. Elements with similar chemical properties were arranged in the same vertical columns. He had left several empty space in his periodic table to be filled by elements yet to be discovered, and he was successful in predicting it. Then we have Henry J.G. Moseley. Okay, he arranged the elements according to their increasing proton numbers. He also left empty space in his periodic table like Mendeleev and successfully predicted 4 elements that were discovered later. Okay, so this is your first exercise. Okay, you do test yourself 4.1 in your exercise book. Okay, so subtopic 4.2 is the arrangement in the periodic table of elements. Okay, so the arrangement is according to ascending order of proton numbers. Okay, so there are two things to be considered in classification elements in periodic table. Okay, which is group and periodic. Okay, so the group is the vertical columns in periodic table of elements. Okay, the vertical column, vertical like this. Okay, vertical column. So these are called groups. Okay, group. Okay, and the periodic is the horizontal rows in the periodic table of elements. Okay, horizontal rows like this. So the horizontal line, the horizontal rows we call periodic. Okay. Okay, how to determine the group? Okay, so we divide the element into two. Okay, the first one with 1 or 2 valence electrons. Okay, you have learned the electron arrangement. Okay, so the valence electrons is the outermost electron. Okay, the outermost. So if the valence electron is 1 or 2, meaning the group is equal to the number of valence electrons. Okay, we will see example later. Okay, so the second one is if the valence electrons is 3 until 8. Okay, if the valence electrons 3 until 8, meaning the group equals to the number of valence electrons plus with 10. Okay, so we will see the example so you can understand better. Okay, so this is the example to find the group and period of elements. Okay, so look at the first example, which is lithium. Okay, so the lithium proton number is 3. So the electron arrangement is 2.1. Okay, because the first shell consist of 2 electron. Okay, so and then the remaining is 1 because 2 plus 1 is 3. Okay, I hope you still remember. So 1 is the electron valence. So the valence electron is 1. Okay, so meaning the group is 1. Okay, and then the number of shells filled with electrons is 2, 1 and 2. Okay, 2 shells. Okay, so the period is 2. Okay, look at calcium. The proton number is 20. So the electron arrangement is 2.8.8.2. Okay, because the first shell can fill with 2 electrons. The second shell is 8. Okay, and the third shell also 8. Okay, that's the maximum. Okay, so 2 plus 8 is 10. 10 plus 8 is 18. 18 plus 2 is 20. Okay, and then look at the valence electron. It's 2. Okay, so 2 meaning the group is 2. Okay, and then the number of shells filled with electrons, you count 1, 2, 3, 4. So 4 shells. Okay, so the period is 4. Okay, that's how you look at it. So the period is 4. Okay, aluminium. Okay, aluminium is 13. Okay, so the electron arrangement is 2.8.3. Okay, so 2 plus 8 is 10. 10 plus 3 is 13. Okay, so the valence electron is 3. Okay, meaning the group is 13 because remember in the previous slide I told you if the valence electrons is 3 to 8 we must plus with 10. Okay, if 3 to 8 plus with 10, so the group is 13. Okay, it's located at 13, the group 13. And then how many number of shells we count? 1, 2, 3. 3. So meaning the period is 3. Okay, silicon 14. Okay, so the electron arrangement is 2.8.4. Okay, so 2 plus 8 10, 10 plus 4 14. Okay, so the valence electrons, the last one is 4. Okay, so 4 to find the group you must plus with 10. Okay, because it is in the range of 3 to 8. Okay, plus with 10, so the group is 14. Okay, so number of shells 3. So meaning the period is 3. Okay, so nitrogen 7, proton number 7. So the arrangement is 2.5. Okay, because 2 plus 5 is 7. So the valence electron is 5. So 5 is in the range 3 to 8. So we plus with 10. The group is 15. Okay, how many shells? 1, 2. So 2 shells, meaning period is 2. Okay, oxygen 8. Okay, so the arrangement is 2.6. So because 2 plus 6 is 8. And then the valence electrons, the last one is 6. Okay, and then you plus with 10, you get 16 as the group 16. Okay, how many shells? 1, 2. So 2 shells, meaning the period is 2. Okay, and then we have bromine. Okay, the proton number is 35. So the electron arrangement is 2.8.18.7. Okay, please remember this. For elements with proton numbers of more than 20, the third shell can hold 18 electrons and the fourth shell can hold 32 electrons. Okay, so please remember that. Okay, for proton number more than 20. So this is the electron arrangement of bromine. Okay, because 2 plus 8 plus 18 plus 7 is 35. So you look at the valence electron 7. So the group is 7 plus 10, 17. Okay, because 7 is in the range 3 to 8, right? Okay, so how many shells? 1, 2, 3, 4. So there are 4 shells, meaning the period is 4. Right, so krypton we have the proton number 36. So the electron arrangement is 2.8.18.8. Okay, plus together you get 36. So the valence electrons is 8. Okay, and then 8 plus 10 is 18. So the group is 18. Okay, number of shells filled with electrons is 4. So 1, 2, 3, 4. 4 shells. So meaning the period is 4. Okay, so this is the relationship between the proton number and the position of elements in the periodic table of elements. Okay, so this is your second exercise. Okay, test yourself 4.2. Please do in your exercise book. Okay, and this is from your textbook. Yeah. Okay, and after you finish doing the exercise, you snap your answer and send to me. Okay, and that's all for today. Okay, see you tomorrow. You'll be having a Google Meet session tomorrow. Yeah. Okay. Take care. Bye.